108 they've joined.
रवि चैट का कोई ये करने वाला है रिस्पॉन्स?
मैं रिप्लाई कर रहा हूँ।
नहीं रवि को करने देना है, लेट, because Ravi anyway going to coordinate the feedback also.
I'll reply to that.
Okay, PDF का तू रिप्लाई कर दे। After feedback form is filled up.
हाँ, गुड मॉर्निंग वगैरह तो कर दे। गुड मॉर्निंग, गुड आफ्टरनून
वो कर दिया सब। रवि वो बोल दे फीडबैक के लिए।
या Deepak, in case I don't say this about the feedback, just make a note of it at the concluding remarks. You can make a
sure.
feedback form will be circulated.
Yeah,
I'll probably do that as well.
नहीं तो मैं डाल देता हूँ, एक मैसेज ही डाल देता हूँ, चैट डाल दूँ?
Yeah, okay. I'm going to mention it in my opening remarks itself. Indeed, yeah. I think there is a slide which talks about it. Okay, I think we should begin.
Yeah.
Good evening, friends. My name is Ravi Raghavan. I am the editor-publisher of Chemical Weekly, and it's my pleasure to invite you to this webinar on running or restarting chemical facilities during and after the lockdown in the COVID-19 era. This event is being brought to you in partnership with the Center for Chemical Process Safety, which is part of the American Institute of Chemical Engineers, and I'm grateful to them for their support. The idea of launching this webinar really came about through some informal discussions that a small group of us had at the time when we heard news about several accidents happening in the Indian chemical industry. All these four panelists out here are alumni of the Institute of Chemical Technology, earlier known as UDCT in the times that we studied there. And all of us felt that perhaps there are some technical solutions that we can bring to the attention of the industry in order to help a better understanding of the issues as well as the solutions on hand.
Ravi,
so that's the...
Ravi, it's not audible. It's not audible, it seems. That's the feedback.
Okay, just 1 second. Let me see. Is it any better now with? Yeah. Okay. So that's the rationale for holding the event. We felt that there are solutions on hand which the industry needs to be aware of, and we are grateful to the Center for Chemical Process Safety and to our two experts from the United States, both of them who live in Princeton, Dr. Anil Gokhale and Mr. Ashit Dalal bring a wide experience in this area, and they will be addressing you over the next hour and a half or so. Just some quick housekeeping rules. As Anil, can you go on to the third slide, please? Anil, can you move over to the third slide?
Anil is on mute.
I am on the third slide now.
Right. Okay. I'm not able to move on to, we don't see the third slide, Anil, if you can just move on. Okay,
Yeah.
there you go. Just some ground rules for keeping some order in the program. I'm happy to tell you that we have at the last time we checked, we had 697 people who registered to attend this event. So clearly there is some traction for the subject, and we are grateful to each one of you for supporting this event. Attendees, all of your microphones will be on mute and your cameras will also be off, so that there is order in the program. The question and answers, there will be a Q&A which will follow both the speakers, and that will happen. It's best if you were to put your questions in the Q&A box and not the chat box. So we're going to be monitoring the Q&A box to make sure that you are able to get your questions answered to the best of our ability. Please identify yourself and your company when you are asking the question. This will ensure priority in the questions. There may not be time to answer all of them, but we'll do our best. As I said before, we will not be responding to anything in the chat areas. So just for the sake of convenience. You can also vote for questions from the other attendees. And lastly, and most importantly, the presentation material will be made available after the event. You will receive an evaluation form, and on filling that form, you will get access to the PDFs which will be presented today. There will also be the possibility of seeing the video recording, both on the Chemical Weekly website and possibly not also on the YouTube channels, and the details of that will follow in due course. So let me get to the conference proper. Let me first introduce my first speaker, who is Ashit Dalal. Ashit is a very highly experienced expert on cybersecurity, risk management, data privacy, EHS, process and functional safety, and he has more than 30 years of experience in manufacturing, consulting, project management, compliance, across a whole range of industries, including chemicals, petrochemicals, oil and gas, and energy. He's a chemical engineer from UDCT, graduated in 1980, and is currently working as a consultant based out of Princeton in the United States. So over to you, Ashit, and the floor is yours for the next 30 minutes.
All right, so thank you. You can see my screen?
Yes, we can.
Okay. Well, thank you, Ravi. Thank you, Anil, for hosting, and thank you everyone for joining in. Good morning, good afternoon, good evening, wherever you guys are. I'm very delighted to present this for one reason is basically it's a kind of something we are giving back to the society and industry. And also I'm getting together with my old friends and colleagues and classmates. Deepak, Anil, myself are from the same batch, and Ravi was a little junior, but he's way ahead when it comes to the, business acumen and other things. So thank you nevertheless. This is very critical and important topic. So we decided that we would give whatever we know and share our knowledge, experience, etc. And at the same time, learn from you guys, because there are a lot of people who have joined with tremendous amount of experience. So I'm just going to go quickly and talk about some of the important aspects. So as this is just a disclaimer, I want to put it, make sure that this is taken care of. No video recording anyway is being done, and the slide would be shared, so there is no issues at all. This is purely for the purpose of knowledge share, etc. So this is the agenda as far as my presentation is concerned. I'm going to focus because Anil and I have some common boundaries, but I'm not going to get into the details of the, the post-startup review and other stuff, or pre-startup review, etc. My focus will be mostly on EHS, loss of containment, process safety, PSM, and cybersecurity, which is very, very critical and important topic, and we'll talk about it a little later. So this is a little bit of my introduction, which you anyway know this. I have a degree in chemical engineering and MBA. I'm a gold medalist from Jamnala Bajaj, and all those certifications which you are seeing is all active. Almost 25, 30 years in industry, as Ravi has already said. So when we started this one, I think, sorry, I'll go back. This is Bhopal. Everyone knows what has happened on the fateful night of December 3rd, 1984. Largest environmental tragedy in the history of chemical industry. And it has impacted so many people. 2008 people died, and permanent damage to several people, etc. And just $350 million, which is basically the kind of damage that was estimated at that time. In today's value, it will be much more. But this set actually was it sets the ball rolling, and it initiated a lot of other things in terms of PSM. So why we decided to go with this particular webinar today is that series of accidents that have happened in last 3 or 4 months since the time COVID has set in. And most of you are aware, and these are specific to India. I have not taken any of the US accidents. So these are basically one, LG Chemicals, everyone knows what happened, 11 people died. PNN Life Sciences, which is Harsha Organics, they have given on lease this to a company based in Hyderabad, Piperazine Recovery Unit. 3 employees died due to the blast. Then you have Khanda Biofuels in, again, Telangana. Same thing, 2 workers killed. In Kurkum, Pune, which is Kusum Chemicals, there was fire incident, no casualty, but damage to equipment and assets. Hemani Industries, pesticide intermediate plant, again, workers died and 3 got injured. And again, in Bharuch, you had the blast killing 10 migrants workers. And I was told that there are about 250 million rupees penalty was levied by the National Tribunal. So this has triggered, we need to think about it, why this is happening. So these are some of the factors that I have analyzed based on those accidents. And most of them are common. And many times these factors are common. Even in the US, we have seen untrained casual labor, lack of communications and training on safety policies, procedures, lack of process safety protocols. Most important in none of those places, and more so in the small and medium scale, there is very clear absence of proper EHS and security risk assessment before and after starting the plant lockdown. There is no guidance in taking inventory of storage material in the pipeline, reactors, equipment, storage, maintenance and integrity of check of the equipment, ICS, PLC systems, piping systems, because if the plant is shut down for 2 or 3 months, this is something which you need to do. And that is one of the reasons why the, trapped styrene in the storage wall in LG Chemicals plant possibly triggered that explosion. And the lack of incident response and emergency action plan at the individual site level or the facility level, and maybe at the industry level, possibly, especially when you talk about small and medium scale, could be one of the reasons. And most important, there is a lack of governance and oversight from the leadership team, which is one of the most critical factors if you have to look in from the point of view of a root causes for this accident. So this is something which is one of my favorite books, which is called HSC Executive Book of 2003. And when this comes from the UK, and I took this chart from that one. And if you see the pie chart, which is little hazy, but you can see that almost 60% of this comes from the poor specifications and design and implementation. And balance is coming from the commissioning and installation and some of the other factors. So at the design stage, you have to incorporate so many other factors, which I was telling you, including the training, including the EHS and process asset analysis, etc. So this is going back almost 17, 18 years back, but it still holds today. And most of the accidents, if you analyze, this could be one of the major things that you might want to see. So as I said, the PSM, process safety management, came into being because of the Bhopal incident. OSHA in the United States, which is the federal government agency, in 1992 came out with this legislation, which impacts all the hazardous industries, and section 1910.119 or 29 CFR 1910 as we call it is the the key federal legislation where that entire responsibility from the point of view of the management of hazardous industries is vested with the senior management, and they are held accountable. So this is a quick definition: any activity which involves highly hazardous chemicals, including use, storage, manufacturing, etc., or an on-site movement of such chemical, the combination of these activities. And this is all considered as one particular area. Now, many times in complex chemical manufacturing plant, and I've seen that very times in during my auditing and consulting area, many chemical facilities, the whole facility may not be under PSM, but the section which deals with the hazardous chemicals such as chlorine or ethylene oxide, etc., they would be basically will be part of the PSM. And some of the triggers here are whom the PSM would apply. Most of you know about it. But general rule of thumb is that if any flammable liquid with flash point of below 100 degrees Fahrenheit on site at one location, if it stores more than 10,000 pounds or roughly 5,000 kilograms or 5 tons or more, would be impacted or would be covered under the process safety management. Now, importance of PSM is, I was just telling you that whether small or large doesn't matter. Though PSM per se, I mean OSHA per se may not be applicable in India, but the process safety management principles do apply. And this is something which I would always insist to, regardless of the chemicals in a facility size, whether it is with 5 people or 500 people, you want to make sure that you have a proper process safety management program in place to ensure that the safety and environmental health safety protocols are properly implemented and regularly reviewed and audited. There are 14 elements of PSM, which if you go to the OSHA legislation 1910, it will give you. And some of them I have highlighted in red, and there is a reason behind it. Is the reason being when I later on in the presentation, when I mapped with cybersecurity, some of these are the elements that would go hand in hand with cybersecurity related concerns for chemical process industry. So this is, I think everyone knows, most companies, whether they do it or not, that's really a question mark. But this is the starting point. You have to carry out, based on the asset value, etc. You need to carry out what is called as the risk assessment, and where it's a classic case of old age stuff where you have the frequency or the probability of occurrence, and also the how much impact it would create or the consequences. And if you see right hand side, anything which is serious or high impacting, you need to take care of it very, very meticulously, and you should have. So PSM would focus around those areas that if you see any facility having that kind of hazards from risk perspective, that need to be addressed. It is very similar in the PSM. The starting point is process hazard analysis, PHA, where a variety of methods can be used, hazard absorb studies and stuff like that. It's the same thing where you have a risk ranking matrix. That would be the starting point. That would give you an idea what would be the risk from EHS perspective, and the same will be extended to cybersecurity as well. Now, this is very important slide because this shows that independence layer of protection. When you have a hazardous chemical plant or oil and gas or a petrochemical refinery, you need to start with the basic level where the process where actually is taking place, whether it's exothermic reaction or absorption or distillation. And then you go to the what is the process control scheme, including the alarms, operators or manual intervention. And then you need to have what is called the safety instrumented system or ESD. And then you have physical protection, because if that fails, then at least you have a physical barrier such as ruptured disc or a safety valve that would take over. If that does not, then if you have another boundary where it can be contained locally, and if it doesn't, and if something like Union Carbide happens or something like LG happens, then you need to have a meticulous plant emergency response or emergency action plan, or incident response plan as number 7. And if you see that these are all independent of each other, so if one fails, second takes over, and so on and so forth. And that is why you try to call as the independent layers of protection to make sure that the EHS impact is minimized in case any such event happens. Now, this is the typical LOPA layer of protection analysis I did for the batch chemical reactor. And if you see that this is what I have done is that translated the previous slide into some of those layers which you have seen, layer 1, layer 2, layer 3, etc. And finally, in the after layer 5 and relief valve device, if it gives away, there will be release on, there is a probability if it ruptures, then what would happen. And really, if it happens, if the release happens is at the large scale, then you have to invoke your emergency action plan. Now, one of the most important thing, both from environmental health and safety perspective, is what is called as the loss of containment. And this is very critical aspect to be considered during process design, engineering, and operation and maintenance phases of any chemical plant, whether it's a small size or the big one. And this includes the pharmaceuticals and other industries as well, where the a lot of hazardous solvents and gases are used. And some of the key factors responsible for loss of containment or LOC, please do not mix it with line of control, which we have with our neighbor. This is loss of containment, so it's also called LOC. So you have inadequate EHS risk assessment, which we talked about it. If your equipment is poorly designed, if you see that HSE handbook, which I have said, 60% of that comes from the poor specifications and design. Equipment failure due to mechanical integrity issues, inadequate preventive maintenance or regular maintenance, not doing proper reliability analysis, and also management of change. Human error and negligence, which we have seen in most of the incidents that I've talked about in last 4 or 5 months. Human error and negligence was one of the major things. Lack of emergency action plan and incident response program. Classic case was Bhopal, classic case was LG, and so many other incidents that we have seen. And then most importantly, the absence of effective material verification program or MVP for ensuring the proper usage of equipment, piping system, and instrumentation. And you must know what is the inventory, because if the plant is shut down for 3 months, and if you have, say, for example, styrene monomer, or some chlorine which is entrapped, or any such hazardous chemical which is entrapped, and if you suddenly loosen the valve just for the maintenance before you start your plant, or replace it before the plant, and if not adequate proper MVP is done, then that can lead to the environmental or the health and safety disaster. So this takes us to what is called as the mechanical integrity of the equipment, and we call it as an inspection, testing, and preventive maintenance program. And ITPM is one of the major areas of very important considerations from process safety perspective. And there you have to consider every equipment type-wise, class-wise, what tasks they perform, what is the basis like applicable codes and standards, ASME, DIN, API, etc. All required tasks to be completed as per the requirement and personal qualifications and procedures. So this takes us now to the cybersecurity and safety. I have about 10 minutes. I'll try and go through this. One of the things I have found here in the US, which is increasingly, because chemical industry is a part of critical infrastructure, as announced by President Obama way back in 2012, where cybersecurity is considered very critical for all 16 infrastructure industries, which includes chemicals, petrochemicals, oil and gas, energy, etc. And I have seen, and I mapped actually cybersecurity related issues with PSM, and the strategy that I have come out with for chemical industry, because of the sheer nature that safety and security, they have to go hand in hand. So if you have a EHS or safety concern, there will be some kind of cybersecurity or a security concern that you cannot neglect it. And this slide talks about it. I'll just go over a little quickly on this. So before we get into that, one of the things which we see is alarming. Now, this slide shows you especially details of how the alarming system or alarm management system should work. The one which you are seeing in the chlorine storage system, which is actually part of one of the actual audits I did. And they have what is called as a dilute system, because this is under OSHA PSM, and they have several sensors. Now they are on independent network, and this is not connected to internet. So if someone tries to get in and disable the alarm, that is not going to happen because it's on a completely separate internal network, hardwired, and they test this alarm at least for every shift. This is tested. The thing is that chlorine needs to be detected at 1 ppm and above. If that is there, the dilute system gets activated, and so no chlorine gets out of the system. It's a very close and highly protected system. But the most important thing is this is not hackable. So if someone tries to hack into it, they will not be successful. Now, these are some of the standards and, both safety and security. When you go to the slides, this is a comprehensive list. Many of them are US based, but many of them are global, like OSHA. Then you have responsible care program, which is very much applicable in India as well. Then you have the NIST standards, 800-82, 62443 for the industrial control system, and so on and so forth. Now, these are some of the cyber attacks that have taken place over last several years. What you are seeing in yellow, these are very specific to chemical industries. And once you get this slide, you will see that. One thing I want to tell you, the most important one is the Triton malware of 2017, a highly sophisticated attack on Saudi oil giant with Tricon X safety instrumented system. Hackers got into it. They tried to disable the system. But the hacker who did that, actually, and their whole purpose was to create an EHS incident, either explosion or the fire or whatever it is, because it was the hazardous plan. But fortunately, when the code was executed, it brought the whole plant into the safe shutdown mode. And after that, Schneider Electric made necessary changes, and also making sure that you cannot put that switch on the normal mode or the program mode. It has to be also secured physically. So this has become a big case study. This was one of the first instances where safety instrumented system was targeted to create a huge EHS related issue. Now, this is something which I mapped out, cybersecurity and process safety, though they go hand in hand. So when you're designing a plan, please make sure that you have environmental health safety and process safety on one side, and cybersecurity consideration, including cyber PHA, which we see on the right-hand side. They would go hand in hand. And the framework which you possibly want to look at is the NIST CSF, cybersecurity framework, which is coming out of US, but it's more or less a global framework now. And this is process safety risk management. Again, I try to put it in a very simplified version, making sure that how safety and security, they would go hand in hand, right from identification, design, up to implementation and emergency or incident response plan. So security and safe design, they are integral part of the chemical industry, or any industry for that matter, which is, we call it as a process industry. And those aspects should be considered right ab initio or upfront, just to avoid any catastrophe at the later date. Second thing is, you need to segment your industrial network from the IT network, and making sure that you are able to have unidirectional flow, remote access to industrial control system network from enterprise IT network should be restricted or not allowed. Actually, in nuclear industry, that is completely not allowed with the air gap and also 10 CFR legislation in the US. And this is what basically I call this, I really like this slide, because this is a cyber physical system where we try to marry cybersecurity and process safety convergence, where software, safety, people, equipment, all the communication controls, etc., they are integrated cohesively so that they walk and work together. These are some of the best practices which I consider as enhancing your safety and security in the chemical industry. Most important, you want to have a layer of defense, either from cybersecurity or on PSM. We have seen independent layer of protection. You must develop what is called as the necessary integrity plan, necessary governance from the senior management, looking at the common causes failures and try to reduce them, and also making sure that any changes you make, that goes through a proper change management process, both at the safety level and the security level. These are my 7 commandments for effective process safety and cybersecurity integration program. And this is applicable to any chemical plant. Don't tell me that if you are from a small scale or the medium scale, this would not apply. This would apply to as much as DuPont to a small company in Ankleshwar or in Telangana district. It doesn't matter. It should be very strictly followed. And these are the 7 best commandments, I would say. Most important thing, and I have put that at the top, is the leadership commitment and the governance, and also continuously reviewing the EHS and the security posture on a continuous basis. These are some of the most important things you want to do. These are my final thoughts. Process industry executives should take the responsibility and accountability, adopt the risk-based approach towards EHS. And Anil is going to talk about pre-startup reviews and other things. In that, he is going to talk about that. And one of the most important thing is there has to be a continuous awareness, training, communication on EHS aspects, and also making sure that everyone works hand in hand as a team. And this is my punch slide because this is my role model. And I always say what Bruce Lee does. He says the highest technique is to have a no technique. My technique is the result of your technique, and my moment is the result of your moment. And this is the kind of defense which we call it the Bruce Lee defense that you need to have: safety and security, and health of your chemical plant or facility. Thank you very much for giving me. Then this is my contact details. Chemical Weekly also has my all details. And if any questions, we will take it at the end of the day. Over to you, Ravi. I finished in time, 1 minute before.
Thank you, Ashit. You did finish much earlier than I anticipated, and thank you for keeping the time. We have a number of questions, but we will, as I said earlier, keep it till the second presentation is also over. I've got several requests on the chat related to the presentations, and I think I'll repeat myself out here. The presentations will be made available to the audience participants after in a couple of days' time. You will be sent a link with the registration form and with an evaluation form. My apologies. And on completing that form, you will get access to the presentations. The video recording will also be available on the Chemical Weekly website. Okay, so without any further ado, let me just turn to the second speaker of this evening, Dr. Anil Gokhale. Dr. Anil Gokhale is Director of Projects at the Center for Chemical Process Safety. So he has been the key person, one of the key persons behind this program. He is responsible at CCPS for all the projects, programs, and educational offerings that they have. CCPS has operations in Mumbai as well, and you can get in touch with them. He has published very, very extensively, has more than 35 years of experience across the globe in the chemical industry, and he joined CCPS about 3 years ago, and is now covering both technical leadership and business executive roles. Again, a chemical engineer from UDCT, the 1980 batch. Over to you, Dr. Gokhale.
Thank you, Ravi. Are you able to see my screen?
Yes.
Okay. So I'll start with the basic laying out the ground a little bit in a bit of an introduction on what is CCPS. It was formed after the Bhopal incident that Ashit mentioned. The industry actually came to the American Institute of Chemical Engineers and asked it to form a directorate that is focused only on safety issues. Then 85 April, we created that. Obviously, I wasn't there at that time. The CCPS was created with a vision that is focused on protecting people, property, and environment. And obviously, as you all know, COVID-19 has already disrupted many things in our lives, including people, and a huge potential to affect both the property and environment. And that is why CCPS is interested in helping the industry to fight this battle. Just a bit of a background, since 1985, CCPS has published over 100 books, and I will mention a few of them. The RBPS, or Risk-Based Process Safety Framework, was published in 2007, and we believe it's a great leap forward compared to the OSHA 1910.119 regulation that Ashit mentioned. RBPS is based on 4 foundation pillars and 20 elements. And I will describe to you a little bit about those, only just a handful of those elements in a few minutes. So what is CCPS? CCPS is a member company organization, not a individual membership organization. We have now about 222 member companies from around the globe and growing every year. You may see a logo of a variety of companies here, small, medium, large, both from regional entities to multinational companies. And some of them you may be familiar with or have worked with in the past. Again, it's a global organization with offices in all continents. Sorry, this is the set of flags that represent the various countries that we have member companies in, and you will see that it is spread in about 41 countries as of right now. Next, we have a list of companies that are headquartered in India and that are CCPS members. Some of these names are well known in India and around the globe. Some of them are perhaps not as well known, but they are all member companies and they are all active in CCPS processes. I quickly want to show you other list of companies who are headquartered outside of India, but also have a strong presence or operations in India. Just to give you give a heads up that we do have a global support structure in place. I wanted, before I dive into the details, here is why I think CCPS participation is so important. One of the very important aspects of CCPS membership is a belief that sharing knowledge benefits everyone. And like I said, that's why CCPS in my role is here to provide some guidance. This includes sharing best practices about process safety, as well as details of what happened behind the incidents as and when they happen. You may think this is contrary to many cultures around the world where hiding undesirable events is pretty much the norm, but even in those countries, CCPS members have very often shared learnings from others, as well as letting others share from their own mistakes. And this benefits everyone, because if you have an attitude of learning from others' mistakes, you tend not to repeat those mistakes. In other words, process safety is not a competitive issue. So that is why sharing is very important. So what is CCPS offering the industry and its members at this time? I have listed the CCPS website, particularly the monograph page here at the top of this slide. And like Ashit said, you will have access to these slides very shortly after this, so don't try to write it down in a hurry. To tackle COVID-19, we published several documents already. And on this webpage, there are several documents. I just want to point you to the top 3 here, and I will cover all 3 of them in my presentation in the next few minutes. Going to the first one, which is the CCPS monograph on process safety under the umbrella of COVID-19. When this idea germinated, we brought in several experts from the industry to ask them what they are doing and what they are actually going to do and share their expertise. Some of their names are in the acknowledgement section of this particular document. This monograph uses RBPS, or risk-based process safety, as its backbone because those principles are applicable at all times, good times and difficult times. We firmly believe that, and hence the reason for using RBPS. And all hazards are not equal and risks are not equal. That is why you have to manage your resources selectively on wherever there is highest risk and so on. As we continue to operate the plants, the need for managing process safety is not really any less critical. Perhaps it's even more so has been made obvious by a list of incidents that Ashit mentioned a few minutes ago. There has been major impact. Why is that? Because there has been a major impact on resources, on everyone, and this includes human resources, material, equipment, supply chain, financial resources, and so on. And they all affect process safety. That is why having the discipline of risk-based process safety is very valuable to maintain. And this RBPS, as I mentioned earlier, has 20 areas or 20 elements in it that allow us to manage process safety in a very clear scientific manner. And this document, the monograph that I'm talking about, identifies some key points that are very unique to managing process safety under the shadow of COVID-19. So please do read it. It is available to everyone. You can access it on the CCPS website. And the one on the left is what I just talked about. It contains all the guidance on all the 20 elements of process safety. The one on the right is a little bit different. On May 4th, we convened a panel of safety experts from 8 countries around the globe in 4 continents, including India. We had a presentation there. And they individually discussed, these experts discussed their own best practices and challenges as they are facing now. What have they done? What are they doing? What do they intend to do? And so on. And that discussion covered a lot of different topics on process safety. This was, again, the audience was again global, and we had invited them to ask questions and also vote on what their priorities were. All that is recorded in this document on the right side that I call practice, as in actual practice of process safety under COVID-19. And you also have access to that on the CCPS website. The recording is in the members area, but the full transcript is available to anybody who is interested. So please do take a look and use it freely for your own benefit. Like I said, there are 20 topics in RBPS, but today we have limited time. So I will address only a few of them. I will start with the operational readiness and PSSR, briefly touch on the management of organizational change, and then go on to discuss process safety culture as well as process safety leadership, because I believe those are top 3 critical topics from the industry's perspective, especially that in India. So let me start with operational readiness. As you know, this is going back again to 1986. As you know, some of the world's smartest and best engineers work at NASA. But what happened in 1986 is a big puzzle, perhaps, considering that in mind. Challenger blew up shortly after the launch, and there was a fairly detailed, extensive study done on what were the root causes of that. I just want to point out to one of those root causes. Thycol, the manufacturer of the O-rings that were the primary failure point, had specified that the operating temperature must be above 53 degrees Fahrenheit at the launch time. Actual temperature was only 36. So why did the launch go ahead? Was there pressure to bypass the safety concern and still go ahead to launch? What do you think was the operational readiness of all the systems when the launch sequence was started? Was there non-technical pressure by the political as well as senior management to just go ahead and do it? NASA had a large success before this accident. So was there, you think, a attitude that was built because of that nothing happens to us? Yeah, or in Hindi, you can say, kuch nahi hota hai, just go ahead. All of the above actually is true. So this is a classical case study in understanding what happens when you do not worry about full operational readiness when you undertake such a significant venture. And this applies to the chemical industry also. This is not just limited to somebody else. Keep that in mind. Many of the plants have been idled, and when you restart them, the same operational readiness principles apply very much, and I will give you some specific examples of those. Why is that? Because it has been well documented that a significant number of incidents happen during the startup. Things are very different during the startup compared to normal operation, and that is part of the reason that the startup times are a lot more difficult. We are actually in the process of publishing a book on transition times, process safety during transition times, and that includes both startup and shutdown. It should come out sometime in the fourth quarter of this calendar year. That describes a significant guideline on what to do and what not to do during this time frame. If your plant was shut down, or facility, or maybe just a process unit because of COVID-19, then this is very critical to understand. Many facilities had stay-home orders or lockdowns, but even if you didn't shut down in a hurry, it is still critical that the startup plan that you may have is reviewed thoroughly and updated to understand the critical needs, because they are different today than they were on a routine startup, both from equipment as well as staffing perspective. Things have changed, and you may not have full complement of all your people or contractor personnel available today that you did in the past. If you shut down in a hurry, then things like items left over in the inventory or open lines or vessels, these are dangers lurking that need to be taken into account, fully studied, and because they are a loss of containing just waiting to happen if you're not careful with those. So here are some pointers, and this list is not complete and certainly not exhaustive, and each facility must have their own list. There are some items that everybody should look into, obviously, and for example, when you are idle, do you try to take advantage of the time to train your staff? What was the last time they actually went through a startup process? Because many of the continuous operating processes, you may not have had a startup in 2, 3, 4 years. Have they forgotten how to start up the process? Perhaps they have. So a retraining at this juncture before you attempt to restart is very critical. And that might lead you to think about a variety of different things, which may end up being some instrumentation, which is important during startup and perhaps critical, but during normal operation, perhaps not necessary or not as valuable anymore. And if you didn't pay attention and fix those things if they were not working, then you are asking for trouble as you start up the plant again. The example of the BP Texas City incident comes to mind along this line. Also, equipment lineup may be different for startup, or if you have not checked that thoroughly, it's critical. There is a process called walking the line, and make sure you can do that and be fully confident that you have the proper equipment lineup in place before you get into the startup process. I want to try and show you a couple of different resources that will allow you to do a better job of understanding some of the risks and perhaps the mitigations also. On the left is a 2-page document that was recently published, and it's also available on the CCPS website. It again focuses on the fact that disproportionately higher amount of incidents happen during the startup process. It provides actually detailed pointers on key items during the restart. It was published by the International Council of Chemical Associations, and CCPS obviously contributed to that and supported its publication. The key reference in that document, the 2-pager on the left, is the CCPS book on PSSR, or Pre-Startup Safety Review. This is the book on the right-hand side, and it is available, has been available for some time now. and it has some valuable guidance on how to manage your startups and what precautions to take or checks to perform before you restart or start a facility. I believe in today's climate, that is a very critical book. And if you don't have it already, for those of you embedded into process safety, this is a must-read document. Let me move on quickly. Time-wise, I think we are doing okay. And talk about management of change, and actually focus a little bit more on management of organizational change, which is critically and integrally tied with the MOOC protocol. When the plants have to operate with reduced staff, it means some people have to take new or additional responsibilities. And this can lead to prioritizing things because your number of hours is still the same and you're taking on more work. Some things will just not get done, and people have to decide what is more important and what is not, and that can cause to some problems. For example, you may have something written down in a procedure, but everything that is in a procedure may actually not happen, and that's a risk that you take, and that can lead to some significant problems. So reduced staff can lead directly to some issues that you need to be aware of. In one actual plant, I'll give you some examples here. They were trying to be very careful about interactions between shifts, and in order to avoid the transmission of the contagion, they had decided to have a cleaning crew go in and clean all the DCS equipment, keyboards in between the operator change. In order to avoid the contamination, obviously. At one time, a sequence of buttons got pressed on the DCS keyboard, and this is a real life story that happened very recently. The unique set of combination of keys got pressed by the cleaning crew, and a significant change in a process set point was put in. Luckily, the incoming operator noticed that, and fortunately, quickly made the change back to what should be the normal set points, and fortunately the process excursion did not go too far and no accident actually happened. So that's a good thing. But whose procedures actually includes guidance or precautions for cleaning crew changing your set points? Just think about that. It just highlights the fact that things are very different now than they were in the past. There are many dangers like that when you have reduced staff. For example, you may have only one engineer on a shift in a plant. And typically you will know, you should know, you already know that engineers and operators also try to consult their colleagues when they have to make critical decisions on the fly. And if there is nobody else available for them to do that, there is a potential problem because they have to make those decisions and they perhaps don't have enough time to make those decisions to call in expert help. Those are the kinds of risks that need to be accounted for when you look at reduced staff operation. Same things with dealing with actual processes and procedures like confined space entry. This is a procedure where it is pretty much a mandatory requirement in almost all countries that you must have a companion with you when you go into a confined space because of potential limitation of oxygen availability. But if you have to do social distancing, how do you do this business of having a companion with you? That's a different problem today than it ever was before. So new procedures have to be put together to address this. Again, like I said, engineers, operators tend to bounce ideas off of their colleagues. And when the subject matter experts are working remotely, it takes a lot of additional discipline to reach out and not take shortcuts. Some of you may know about the incident at the Longford plant in Australia. It's a classic example. And there are several root causes for that. But one key major factor was that the facility had relocated most of their experts to work remotely, and they had sent all their this plant is out in the middle of literally nowhere. So people were sent off to work from a bigger city, and they were working remotely. And that was, in the investigation that happened afterwards, that was one of the key root causes, because of lack of availability of the subject matter experts led to making decisions that actually was a direct cause for what the explosion that happened in Longport. So when you have your subject matter experts working remotely, you need to have a strong protocol on how to have access to them and so on, because shortcuts will be taken. And I will talk a little bit about how to not to take shortcuts in a minute here. For managing the organizational change, here's some examples that you should consider. You should have a protocol in place that minimizes the contact, obviously because of the contagion, but still figure out a way to have critical communication just like before, without any reduction in the intensity of the critical communication. What are the risks and how are they mitigated? Those are, if you don't have critical communication just as before, that's something to be thought about and planned for well ahead of time. Some companies, for example, have suspended shift change handover meetings that happen between the team of operators and engineers, perhaps, so that the teams are kept separate and you don't have cross-contamination. This can lead to missing information transfer on some key items. In one site in Europe, just very recently, there was an ongoing repair in one facility that was not finished by the end of the shift. After the shift change, new person came on, and he was not aware that the particular equipment was under repair, and he tried to restart it. What happened was an accident, and he was injured, but luckily it was limited to just injury and did not get any further. So if you had a handover procedure in pre-COVID days that required discussion of equipment that is not ready to start, you still need to have similar discussions happen even without direct contact or face-to-face meetings that are common during the shift change. So have to figure out, you can't just hand over and say, I'm done, I'm out of here, you take over now. There has to be communication that is very critical. I want to mention a book that CCPS published that is on the right-hand side of your screen, which is Managing of Process Safety During Organizational Change. And in that book, it's a very valuable book to have, but in that book, a specific item I want to point out is called Activity Map. And you will see the details there. What this activity map allows you to do is document thoroughly what are the different responsibilities for different people. That includes leaders, managers, operational leaders, shift supervisors, engineers, you name it. List their responsibilities as they were before the COVID-19 and see how they transfer to the new staffing arrangements that you have. Make sure that all items are covered and evaluate the risk of having people loaded with multiple things that were not before. And this activity map will help you clearly document what new risks you have now taken on and allow you to have mitigation factors put in place to be able to deal with those. Okay. Moving on, I want to switch to the third topic I had mentioned, which is the process safety leadership and process safety culture. Leadership is critical at all levels, not just the CEO or top of the organization. As you probably already know, leading is what good leaders actually do, and that's very different than managers. Leading is not the same as managing. Every organization should already know what individuals should already know what their role is as a leader and execute it, especially now in the time of COVID. In the situation that we are in, people are very anxious and they want to hear from good leaders a whole lot more than usual. They may not speak up unless they feel the kinship with their leaders. And what some of the leaders are doing is having Video calls, group meetings, town halls are some good examples of what leaders are doing. Some CEOs are actually sending out small but very effective messages to their whole company almost every day. And the key word there is effective. You don't want to distract the teams with messages that don't add anything to either their morale or their work practices. Some people have their staff quarantined, and those people are checking on their direct staff on a daily basis on how they are doing, looking after their families' welfare and so on, and that builds a lot of trust in the management of the company. Because remember, when what leaders do and behave in the time of stress is something that is remembered by everyone for a very long time. So this is a critical stress and test time for all people who want to be or already are in leadership roles. We talk about work-life balance and avoiding distraction, but as we are dealing with the pandemic, we may be surprised what people are thinking about what is really the distraction and what is really the primary responsibility. So people's focus may be shifted, and that may lead to their effectiveness, and that is something that needs to be taken into account, that they have other priorities outside of work, such as their family's welfare, that are very important on their mind. Building trust with the people is critical, and that goes hand in hand with the communication, as I mentioned. When facilities are running on reduced staff, every employee, every contractor should feel the responsibility to raise safety concerns. And you may have heard that many companies around the globe are looking to eliminate staff just to reduce expenses. A good leader will make sure that these actions are not going to affect the good process safety judgment of their employees. It's a critical task because you do want people to step up and point out potential dangers before they turn into bigger problems. Two more items. One is the sensibility, sense of vulnerability from a process safety perspective that CCPS always wants people to be aware of. Just because you have additional sense of vulnerability due to the pandemic doesn't mean that the process safety vulnerability is actually reduced by any means. Actually, it perhaps is even worse today. Then the other common factor is I mentioned about shortcuts. When people are overwhelmed with the work, they tend to take shortcuts and bypass the established processes. This is called deviances, and they can easily and quickly become normalized. And the normalization of deviance becomes a practice, and that is a big danger lurking, leading to potential incidents very quickly. It's just bad practice and risk taking that should be avoided without any approval levels. No shortcuts, even though you may be short-staffed. That's something to keep in mind. So people are going to ask me, I'm sure, and they already have, how do you measure culture? We can measure production, we can measure temperature, but what's this culture? How do you measure it? It's a very intangible thing. And I want to give you a simple tool for you to see how well is your culture, committed culture from a process safety perspective. This is available on the CCPS website also, and the link is at the top of the page. This is a spreadsheet that you can use to do an assessment of your own organization. And I'm just showing you a small snippet of what is in this spreadsheet. I don't want to show the whole spreadsheet because then it'll be unreadable. There are samples from 3 different categories here. They are all related to process safety culture, executives, supervisors, and managers. And there are some specific questions. If you have a chance to take a look at this, download this file, and do your own assessment as to how are some of these things handled. For example, are they done always, sometimes, once in a while, Not really. And that spreadsheet will actually score your response. You don't have to share it with anybody. It's just for you. So take a look at that and see what you think is your process safety culture look like, and it will make you either feel very good about it, or it will open your eyes and it will point you to things that really need a lot of attention. One way or the other, it's a good practice to take a look at and decide where do you stand on your own. This is a test for yourself, not for showing it to anybody. One more tool I want to show you is about lessons learned. I already mentioned to you about one of the things CCPS promotes strongly is learning from other people's incidences and allowing others to learn from your own lessons. And this is a table that allows you to measure the maturity of learning from past incidences, your own as well as others. And some examples may be when you have incidences that are happening, like I discussed, like Rashid showed a long list of them that have happened in India. There are potentially lessons that can be learned by everybody as to what went wrong and how can that affect your organization. So it's an interesting tool to look at and do your own scoring when time permits. Okay, here's an example of a poll, and I want to show you some quick results that we looked at. And I will not read all of these different lines, but let me just cover a couple of them. Let's see. Let me start with the last one here. The subject matter expert's opinion is consistently included in decisions, even if that adds delays because they are remote. I think this is a sign of a very strong process safety culture. What we are looking at is simple binary decision. Is this an indication of a strong process safety culture or a weak process safety culture? So I believe this is a sign of a very strong process safety culture. Now let's look at one more. Number 4. Companies are reducing staff and employees are afraid of job security. So they will not raise process safety concerns that they see. This is a sign of a very weak process safety culture, and so on. So I'll let you read the others as the time permits, because we want to save some time for question and answers here. But I want to give you a test. You heard a lot of these incidences in India. I keep coming back to that because our audience today is very India-centric. So let's pause and think about them and reflect on your own reaction. What did you think when you heard about these incidences? Did you think that all those things happened because those people don't know what they're doing? I do. It can never happen here. Or did you think, what are the root causes? Can that happen to my plant? Which category do you consider yourself in? Is it A or B? I'll pause here for a second or two and let you read all those line items in both those boxes and rate yourself for, see what you think, where you are. Unfortunately, we don't have a poll, so I can't judge how many are in A and how many are B. But my hope is that most of you are in category B, and that is why you're interested in this webinar. So that's a short quiz. I hope everybody passed. So I will give you 2 more resources for understanding the concepts of process safety leadership and process safety culture. The book on the left focuses on process safety culture, which is unique and very distinct from process safety leadership, because like I mentioned, leadership happens at all levels of the organization. We have responsibility as a process safety leader, irrespective of what our title is or what our role is. And if you're not familiar with those concepts, please do try to get these books. and read them. They will be very beneficial, I believe, to anybody who is involved in process safety. The CCPS website I have referred to will tell you how to acquire these books. Those of you who actually work for CCPS member companies, you already have access to them. And because free copies were sent to you as part of your membership benefit. So find out who is your CCPS representative, and they will have copies of these books available for use by your company. Additional copies always can be had through our publisher. In summary, I want to emphasize that the world is changed, or it's already have changed. It's not just changing, but process safety remains a priority for all operating plants. Let's take a quick look and see what has changed and what has not. For example, who amongst us had actually heard of social distancing 5-6 months ago? I bet there is nobody. And things like limited traveling outside, or not eating out in a restaurant, or the whole concept of a lockdown or a stay-at-home order. We never thought this was possible in any democracy, but here we are. Unfortunately, even though those things have changed, the hazards of chemicals have not really gone away. And as we know, incidents keep happening. And that's a fundamental challenge for us, those of us involved in the business of process safety. I would like to hear back from you when we go to the question and answer sessions, and find out how CCPS can help address your process safety concerns. I have my email address here on this slide, and also my colleague who is in the Mumbai office, Umesh Dake, he's our regional manager. His email address is there on the slide. And with that, I want to pause here and hand back the controls to Ravi. Ravi, take it over, please.
Thank you, Anil, for doing an excellent job of giving an overview of the resources available with CCPS, as also sharing your experiences on how the industry can tackle the risks associated with process safety. I think there is a broad understanding in society, at least in the chemical society, that this industry will remain by its intrinsic nature an hazardous one. But it is a question of managing risks. And I think both our speakers today have given a perspective on how that can be done better than we have been doing in the past. They have shared some of their experiences. They have pointed to a lot of resources which are available with them. And I'm sure that all of you will stand to benefit from what is available. I'm going to go over and start taking some of the questions that have come to me. There are quite a few of them, nearly about 40 of them. And I will go through at least as many as I can, given the time constraint that we have.
Ravi, before you start, one of the few questions I did answer, I just want to mention that many of the questions, they talk about the issues related to the plant startup and restartup after COVID. The reason we decided to do it this way is because of the very fact to avoid duplication, because Anil was focusing mainly on the pre-startup and other areas, and I decided to focus on EHS aspects, which is whether you restart the plant or start the plant or come out with a new plant. So this is the overall perspective I have shared, and then Anil deep dived more so and very, very rightly and logically into the post-startup and the pre-startup review, which is very critical, especially when industry is starting up. Second thing is, one common question is all about leadership, and I try to answer. I think there is a background noise. There is some background noise. I don't know who is talking. So the thing I want to clarify is that leadership, governance, etc., and the safety culture, which both Anil and I have emphasized quite a lot in the presentation, have to go hand in hand, and that would address a lot of those issues which we are seeing. And all the 5 or 6 incidents that I have referred, and Anil can also give a lot of case studies from even in the US where the things have failed. It's not just the process safety related issue, but it is an interplay of many factors, including the safety culture, communication, training, leadership, governance, etc. Go over, Ravi. You're muted.
Yeah. There is a question from Salil Narvekar, and I think, Ashit, it's addressed to you. He says he's studying chemical engineering at ICT, and he calls you Sir. Sir, can you please tell us why you went into cybersecurity from chemical engineering?
So, my dear friend, when we passed out in 1980, people did not even know cybersecurity. We didn't even have the computer. And just to tell you, if Anil remembers and Deepak remembers, we used to punch in Udacity and collect the program at TIFR. So we never, and in fact, we never had even the luxury of using the calculator. It was allowed, I think, in the 3rd year chemical engineering, right, Deepak? We never saw that luxury. There was no internet. Internet was out of question anyway. So I won't say that I have shifted 100% to cybersecurity. A lot of time I spend in that. And one of the major driver for that, especially from chemical industry perspective, is that because chemical industry is a part of critical infrastructure, and having been in the US for last 20 years, there is increasing focus now on cybersecurity. And if the things are not designed properly, especially industrial control system, PLCs and other, that can create havoc. And I have given you the example of the Draconex incident, which happened in 2017 in Saudi petrochemical plant. So what I feel is the chemical engineers are the best suited to look into the chemical engineering aspects, process safety aspects, and cybersecurity aspects. So safety and security will go hand in hand. And some of the things which Anil and I have discussed, like, for example, process hazard analysis, incident investigation, management of change, these are all concepts cybersecurity has adopted. And that is the reason I showed you the comparison. Not including the front-end risk assessment we do. I showed you the metrics for PHA, and I showed you another metrics. Cybersecurity, we do the same thing. So if you are an aspiring chemical engineer, I would request you to look at comprehensively everything: environmental health, safety, process safety, and don't forget cybersecurity. Because it's a question of time when you will be hacked. No one can say that we will never be hacked. Even the company like IBM or DuPont can be hacked. Why should anybody can be hacked? And that's why cybersecurity in today's world is very critical.
Let me add quickly to that. 20 years ago, let alone 40, the process plants were completely disconnected from everything.
Exactly, and that was all analog.
There was no such thing as connected to the networks. Today,
exactly,
because of the sophistication of all sorts of software and computers,
TCP
everybody
IP.
wants to have access to the information at their fingertips. So you have connections from the PLCs and DCS into the office computers,
exactly,
into the corporate network. And the concept is they should be designed with a one-way traffic so that you cannot have outside influence at the low level control. But the reality is, once you build a road, how many people actually just travel in the direction that is posted on the road? You tell me. And how many people find a way to go backwards into the DCS that are not supposed to? So that's how the breaks happen once the pipeline is established. And that's why today cybersecurity is as much of a danger as process safety related issues. And it's a critical part of safety in general, because we have not been completely so-called off the grid. Nobody will consider doing that today as we were maybe just 20 years ago. And that's why cybersecurity has become a important topic for chemical engineers.
Anil and Ashit, I can add something from the Indian perspective. The question is that or my experience is that in India, there are maybe limited companies which are having automation and DCS control. Many of the medium scale, small scale don't have such automations or connectivity through via internet into their, I would say, automation mode, or where cyber security could be affected. So people in India may understand or may not understand the importance of cyber security beyond the point if they are not aware of such some of these incidences which Ashit has mentioned. I think so it is coming up in the last few years that people are taking up to automation. Maybe in the coming decade or so, possibly you will see more and more automation, partly because of these changes in the environment, because of where you are looking for cutting down on the manpower and cutting down on the contract labor. So cyber security in India could play a more important role in possibly the next decade or so, and it will continue to grow.
And Deepak, I will just answer to that. I think you are absolutely right. But let me tell you what we have been seeing, and especially I've been seeing in the United States and so many clients I visit, including chemical companies. All those attacks, including, Norsk Hydro attack, which is ransomware attack, that did not emanate at the plant level. It came from corporate IT side. So you see the business impact. So if suppose Ravi is in the office and he clicks on an email, which is suspicious email, and this is there is a CERT India advisory also, you must have seen last 3-4 days, I forwarded to you. So what happens is that if someone sitting in the room itself, like corporate executive or someone, he clicks on that link, and that is where your trouble starts. And that can, impact not only your operations, it can impact, customer related aspects, everything. So ultimately you see the impact, the business impact, because if you're not connected, you can't do business, you can't do, inventory, accounting, etc. You can't reach your customers, etc. And you are right, it will be still a little in the, nascent stage in India, but that's going to come for sure.
There's a question that I'll pass on to you, Anil. It's from Ashok Bau, and he says, in India, in most industrial accidents, the top management goes free. And he says it's people at the bottom, the casual laborer, the operator trainee, or the shift in charge. These are the guys who are penalized. How do we improve this as government is also involved, clearly?
I can't comment on the government aspects of it, but from a purely engineering perspective, let me add a few words here. If you have a strong process safety culture and leadership, you don't ever point a finger at who did that. That's the last thing you bother asking. Who's at fault is not the question that you ever ask. What happened, why it happened, what systems failed to allow that to happen, and how did the barriers degrade? Those are the questions that you ask. You don't worry about who was the person whose fault it is. But unfortunately, you see that a lot. Is the finger pointing happens first before understanding the root cause of actually what happened. And that culture change will take a long time, and it is not an easy transition to have, because it takes significant process safety leadership at all levels, management particularly, to worry about how do you avoid such incidences from happening to begin with. If you don't understand the root cause and you just, it's one of those things where you shoot first and ask questions later mentality. If that is there, all bets are lost. If your outset mindset of leaders is let's find out what barriers failed, why did the loss of containment happen, what do you have in place? And that's why I put that quiz at the end, saying when you saw these list of accidents, there was a lot of chatter in the news media. For example, who's at fault? And to me, I couldn't care less who's at fault. I wanted to find out what is the root cause. The root cause, I don't have the official report, but all I saw was several things that happened. Perhaps a control valve failed. Perhaps because of that, the inventory in the tank heated up. There was no backup cooling systems. Those root causes are what failed, not the person who was on the board when the accident happened. And when you have that type of thinking is when, and that type of thinking takes a long time to come through the organization. But everybody has to push in that direction for the culture to change. And those changes will happen not just top down, but also from the bottom up. And that's why I mentioned process safety leadership is not meant only for CEOs of the organization. Process safety leadership means everybody in the organization has to have that type of attitude of focusing on root causes and not finger pointing. And the political angle is something that's very different. Cultural angle from a societal perspective is very different, and I don't want to go there. But from a process safety perspective, you have to look at what went wrong as opposed to who did it. Who did it is the last question that you ever want to ask.
And Ravi, one thing is that this also holds for security. Safety and security are the way of doing business. You can't just say that just because someone is coming to audit and then we update our procedures, etc. And this is something which I answered to one of the gentlemen who asked this question. Safety has to be the culture. It has to be ingrained. It has to be the way you should do business. And as Anil has said, it has to be, everyone has to be involved. It's not just one person's job. It's a complete organization responsibility if something has failed.
Okay, there's a question specifically for Anil from Mr. Kuriachin Jose. What are the requirements to do a facility revalidation PHA or HAZOP for a refinery after every 5 years? I think it's probably requires a detailed answer. Anil, do you want to take this or should we keep it offline sometime?
I'll touch it for a few seconds, but if you're trying to do a full PHA across the whole refinery, that's a tremendous amount of work. This is not to be taken lightly, and you perhaps want to tackle it on a unit by unit basis to begin with and have that documented. And then revalidation is required after a certain number of years.
5 years.
5 years. It may change depending on the country, so that's why I'm keeping it open. So that's a lot of work, and it is not something you want to start with. The simplest process that you may have if you have never done it. Get hold of a consultant who has that can guide you, and once you're used to it, you may be able to do it yourself. But you're talking about a significant amount of work to do a PHA across the whole refinery. It's not trivial.
And it's a teamwork, and you have to go with a little bit of a risk-based approach, because again, what is
Agreed.
highest risk, you should start with that.
And I'll say this, as CCPS, we provide guidance. We do not do consulting. So I cannot tell you that I will come to your plant and do it for you. That's not an option. That is not our business. We are a very different organization. So we do not provide consulting services. Unfortunately, that's not in our mandate. So
there's a question from Wasim Akram from Doha, Qatar, and he is in the business of chemical logistics. I mean, are there some lessons for them out here?
Clearly there are. I think logistics to me, maybe perhaps I'm thinking out loud here, means shipping of chemicals on the road. You have some significant hazards there that can involve railroad cars, that can involve trucks, that can involve tankers. And every time you have a chemical that is traveling or on outside your property as part of the logistics, you have to manage what are the potential hazards that you are going to encounter. And not just during the transport on the road, but simple things like when you bring in let's say a tanker of chemicals that you as your raw material into your plant. Are you connecting the right hose to the right tank, and are you unloading it in the proper location? There have been many incidences that happen because when you at the truck loading facility or unloading facility, the type of nozzles that people have installed are identical, and you can easily unload a wrong type of chemical in the wrong type of container, and there goes the incident. So that probably comes under logistics, I'm guessing, but it's not. Process safety issues are not limited to operating equipment. It is limited to rail cars, tank farms. Rail cars, if used to have their nozzles sticking out for the loading and unloading. And when the rail cars got into a derailment or an accident, the nozzles was the first thing that broke and spills happened. So changes were made so that the walls of the rail cars are designed now such that the nozzles are brought inside, and those are the not first ones that are impacted. So those are kinds of things that process safety allows you to redesign. So yes, process safety issues are everywhere that should be taken into account.
And
Yes,
again, I would just add in that they should also look at American Chemistry Council's Responsible Care Code. They have a specific code on both process safety and the product safety. So that talks about, you know, transportations and everything.
Yeah.
And it's a free document available on ACC's website.
Ketan Desai is a research student at ICT, and he has 2 questions. He emailed me these. What precautions would you like to recommend for research institutions during lockdown and post-lockdown when things start getting back on track? And how do we manage social distancing while working in a laboratory?
That's a very good question. I will answer it, and then I'll pass on to Deepak because I suspect he knows a few things about this. We have a tendency to think, oh, it's just a small lab. There is not that much chemical in it. We are just doing experiments. Keep in mind, you have some seriously dangerous chemical things in your little labs, where in your research facilities, and they can lead to significant accidents. If you have a fire in your little lab that can affect you or cause burns, that's a serious incident, and it may not kill hundreds of people, but if it kills you, I think you will consider that serious. And there have been significant number of incidences in small to medium-sized labs and pilot plants that do research. So process safety is just as important. In October timeframe, you can look up the CCPS website for a new book. It's called Process Safety in Plants and Pilot Plants and Labs, that is focused only on this topic and nothing else. So we are finishing up the manuscript now, and we will probably publish it in October. So it will be a very valuable book. It's focused just on people who deal with those kinds of situations. Deepak, you want to add things?
Yeah. See, normally what I've seen in Indian context, the kind of safety importance is given to the plant operations. Typically, the R&D or the laboratories are overlooked. They are many a times in the safety drills or training. Very few people may be involved from the laboratory. I have seen.
That's not limited to India. That kind of problem happens around the globe, unfortunately.
Okay, I didn't know. I didn't know that.
Yes.
But, so what happens is, quite a few times there are serious accidents which have happened and which have not been reported. I know in one case about a year and a half back, somebody who was doing some slightly pressure reaction, the autoclave burst, and the person has lost a hearing facility. So it's something which the person was not even aware of what sort of safety needs to be done, taken during such high pressure reaction. I have personally seen when I was in UDCT doing my PhD, when we were one of my colleagues was doing a high pressure reaction in a glass autoclave. The glass autoclave simply burst. Fortunately, none of us. I was present that time in the laboratory, but nobody was injured. But we were in those days. There was no education in terms of
Safety.
Safety issues. today at least there are opportunities available, and I believe that R&D people need to be involved in this such safety training and safety issues within any organization, whether it is big or small.
And I will add few points. I mean, Deepak and Anil, see, when you do at the lab, because that's one of the very neglected areas I've seen all the time, and Anil is very right, we see all the time everywhere. Few things you need to keep it in mind: the basic safety hygiene, and that involves you will have a eye wash station. Make sure that that's working. So that's under regular inspection. You may want to make sure that the fire extinguishers are adequate. It's adequately ventilated. And second, the exit sign should be clear, that as to if there is an incident, where you should go out. There should be the safety drills and other things for evacuation, and everyone should participate. And also making sure that the lab packs, which are where you throw your solvents and other things, they are properly labeled and disposed of. Because there are OSHA requirements from global harmonized system perspective, hazardous materials identification, waste management, and all those rules which are applicable even in India. So make sure that those are properly labeled and disposed of. And most important thing, I've seen even here, you must wear proper PPEs, and especially in COVID-19. You cannot afford to be lackadaisical in ensuring that you don't wear those PPEs. That would be a major suicidal.
One common thing that you see, it's a very simple thing in labs, in research labs and pilot plant perhaps. Storage of compressed gas cylinders.
Yes.
Those things have a potential to be launched like a bomb, and they can take off, they can do some serious damage. But how many times do you see those cylinders just sitting in a corridor somewhere, or are they
unchained? Not chained also.
Unchanged. They can roll around, they can fall off, and their caps broken and cause serious damage. So there are little things like that that you don't think of, that are serious hazards even in a research facility. It's not really a simple answer.
And there is an NFPA guidance on that. You can look at the fire hazards in laboratory from National Fire Prevention Association in the US. Two common things I have seen in the US in many labs is when you have those cylinders, especially hydrogen and other things are used extensively in HPLC and other tests. So you want to make sure that hydrogen cylinders are kept away from electrical source. And I have seen the autoclaves are tied. There has to be at least 6 feet distance between the cylinder and electrical source. I have seen even the hand sanitizer very close to the electrical source. Now, these are all can lead to the fire hazard. And when fire happens, you would not get time. So first thing is you possibly would like to look at your lab layout, where the equipment are, etc. Do a quick hazard analysis and rearrange your equipment, everything, to make sure that you mitigate that risk as much as possible.
Right. There's a comment question from Mr. Sahasranaman, who was my colleague at the UDCT Alumni Association as well. KS says the US classified the chemical industry as essential infrastructure and many plants did not have to shut down. Shouldn't we have a similar approach in India? And I can a little bit answer that, because I think India did have that approach, but with a little bit of a hiccup. It took about a week or so to declare most of the chemical industry, at least the continuous process plants, as essential infrastructure and allow them to operate. Any of you have a comment or?
Yeah. As far as US is concerned, absolutely right. Chemical industries, petrochemicals, life science, pharma, all are part of critical infrastructure and essential services. So they cannot shut down, they have to run. Oil and gas, obviously, energy, these are all part of critical infrastructure. In India, I guess pharmaceutical is absolutely part of essential services, but I'm not sure about the fine chemicals and other stuff. If someone is making, say, perfumery chemicals, I don't know whether that would fall under essential services or critical infrastructure.
As per my understanding, I think so. After the shutdown, mainly the pharma and food industry was allowed to continue. All others were supposed to stop, including some of the continuous plants. I know one of my suppliers of product for Japan, which is a continuous process, had to stop for about 2.5 weeks. He was complaining because when he restarted after 2-3 weeks, it took him almost 6 to 7 days to stabilize. So except for that, I think so everybody had to shut down for at least 2 to 3 weeks. I don't see same thing happened in Japan and Korea, where I deal with some of the chemical companies there. They in Japan and Korea, all the chemical industry was continuously operating to the best of my knowledge.
There is a let's move on. I think we got more than 80 questions. There's one on from George D'Souza on remote monitoring technology. I mean, is that something which is going to be relevant in tomorrow's post-COVID world?
You want to take that, Anil, or you want me to answer
Anil?
that?
I'll take it. I mean, remote monitoring technology is useful even today, and it has been used quite extensively. I'll give you the example of the oil production platforms that operate in the North Sea or the Gulf of Mexico or many other places that are offshore. They tend to have very robust connectivity to their land-based staff, and they have perfected the art of continuous remote monitoring, and they have routine staff sitting there advising and working with the people who are on the platform, because the platform spaces are limited and you can have only so many people there. So that's a practice that has already have some solid experience, and but in the land-based industry, that is not so common. But there are ways out there that can be leveraged now that we are having a lot of people working remotely. Having the critical internet infrastructure is obviously a requirement there. Sometimes these facilities use their independent satellite-based
Communication
items that communicate. Sometimes they don't rely on the publicly available infrastructure and so on. So every location is different in that regard, but the technology is there today. It has been there for the last several years. It's just not as common on land-based, but it is not uncommon either. I remember 25 years ago, I was sitting in Houston and I was able to monitor a refinery operation thoroughly that was running in Alaska. And actually we were running sophisticated advanced control algorithms from a remote basis. And all we had was a simple T1 connection. So limited the data throughput, but we had that technology even back then, because I really didn't want to spend months and months in Alaska, to be honest. That was one of the reasons we did that, but it's there. It's just a matter of investing in it in different locations in the world.
And this is pretty common in energy industry, like substation and all. If you see that's what basically more or less remote monitoring, because the SCADA control systems are way far. And if you see all those natural gas stations and pipeline, how are they monitored? It's all remote sensing, remote monitoring. So the control room operator who is sitting far away, maybe 1,000 miles away, as Anil has said, they can still monitor those complex maze of pipeline network and other stuff.
Okay, I'm just trying to pick a few which are not repetitive. Okay, here is one from GS Chelvan Senthamil. I believe that even good design of a plant causing more incident due to violation of safety procedure, bypassing the interlock without aware of importance and handling the operation with minimum experience operating personnel. I think the point is about human behavior, I guess.
That's very true. And humans are designed to fail, and they fail all the time. That's why you need procedures to prevent them from taking shortcuts and protocols. The lockout tagout procedure, for example, is designed exactly to prevent those kinds of bypasses. And there are many other safe work practices. But to keep in mind, if a human deliberately bypasses this with an attitude that nothing will happen, I know what I'm doing, I guarantee you something bad will go on. Because what's the difference between a overconfidence person who deliberately defeats the safety protocols and somebody who deliberately wants to do sabotage? Same action, maybe not a intentional sabotage, but the end result is exactly the same. So you have to treat it that way, that the procedures and protocols that are in place that are deliberately bypassed are nothing short of unintended sabotage. And unless you have that sense drilled into the people, you have a problem.
And I think one of my slides, Ravi, shows that the layers of independent layers of protection, where you have a safety instrumented system, then the pressure relief valve safety systems and other things. And also, even if everything is bypassed, at least you should have what is called as an effective incident response plan. And that should be tested regularly. So it's a layered approach, or defense in depth approach, as we call it. And cybersecurity, we have the same thing. Like you keep everything, firewalls, intrusion detection systems, you have multi-factor authentication, but you keep the back door open. That is going to happen. That's exactly happened in the case of Target breach. 45 million cardholders' data was breached about 8 years ago. So same thing applies to safety.
Gauri Shankar Singh has a comment really on inspection of critical equipment before startup. Is that a part of PSM?
Absolutely, absolutely, it is. Perhaps not just limited to critical equipment, all equipment. The pre-startup safety review, as defined by OSHA, actually is somewhat limited to, I believe, only new plants or when plants are changing. But in this COVID business, even though the plant was shut down and restarted without any changes, your concept of readiness review, which includes PSSR, must apply, and you have to go through a full-scale readiness review that includes the PSSR. And that includes all your critical equipment, all auxiliary systems. And I assume that every plant and every facility has a startup plan that needs to be reviewed. And essentially, in light of COVID, it needs to be thoroughly checked to see what new risks that have been added. So yes, it is definitely part of process safety management, and perhaps a very critical part, because like I mentioned, many unproportionally high number of incidents that actually happen during the startup. And that's why the readiness review and the PSSR are a critical part of PSM, yes.
And also update your emergency action plan after you've done the review, because that may also change, because the risk posture may have changed.
Correct.
So,
yes.
So that you need
There is
to
a question which I kind of read, but I lost track of in the list out here, but it talks about accidents and learning from this. And he talks about how do we ensure that the lessons learned are communicated, I think both within the company and in the community of the industry. I think this is very, very relevant, especially in an Indian context. I know for a fact that there is extremely poor communication between companies for sure. And there is a tendency to put everything under the carpet. What is your experience in how this information is shared so that others benefit?
Two parts to that answer. As I mentioned earlier, CCPS strongly promotes sharing of information within its members, but we cannot force people to do that. Actually, like I mentioned, there are countries where hiding the things under the carpet is the norm, and it's not limited to India. There are many other countries, but I will say this proudly that the CCPS members in those countries do not do that. They are very open about sharing their processes, sharing their incidences, just as much as you want to talk about your successes and great results. They also are interested in sharing the incidences. What we do to facilitate that, Ravi, is when we have these meetings and when we have member sharing, we exclusively limit it to members, and we do not allow any recordings, and we do not allow any government agencies to be present. And that allows our members to openly discuss what happened, why it happened, what were the lessons learned, and what others can learn from it. And that's a very important part of CCPS. And our member companies in India also are active participants in that, believe me. Same thing with other countries like China, Brazil, Argentina. They all share incidences where you may suspect that they may not want to. And it takes a cultural shift in the mindset that if I learn from somebody else, it's my duty to allow others to let them learn from me. And it's that kind of mindset that needs to happen purely for the purpose of reducing new incidences.
And I will add few things, Ravi. In this case, they will also can have, in the US especially, what we have, what is called as the Chemical Safety Board, CSB. You can go to their website and their videos are freely available. This is the biggest resource, one of the best resources I have seen for learning. If similar incidents have happened, say in the United States, how CSB has dealt with it, what was the root cause, what are the lessons learned, what should be done to prevent that happening again. And these are videos are posted in CSB's website. Also, DHS comes out with some of the notifications on and off, because the chemical facility from security perspective is under their jurisdiction.
Sanjay Mandale, my good friend from Ion Exchange, has a question on what about inadequate process knowledge of the operating officer and training issues? Clearly, training is a very important part of safety.
I don't know how to tackle that because, like you said, training and knowledge are a critical part of operation, period, not just process safety. And without that, would you put your 3-year-old in front of a steering wheel of a car and let your child drive? What's the difference between that and having a untrained person
casual labor
sitting in a plant and being responsible for things that person has no clue about what they are doing? That's simply a matter of responsibility of the person who's in charge of making sure that you have qualified staff. And if you are not sure, like I said, in the startup, your operators may be trained on the startups 5 years ago. Have they really remembered everything that they learned because of the shutdown? They should have been retrained and should need to be retrained again so that they are refreshed on how to start up a plant. And we're talking about trained people here. So even for very trained people, retraining is a critical aspect. You can't just do training once and say, well, that person is trained, you don't need to do training again. Training is continuous. Knowledge acquisition is a ongoing process that never stops.
Ravi, I will add something to this, what Anil said, especially in India, where there are a lot of specialty chemicals manufacturers with batch processes, and these are done in campaigns. Many a times a campaign may be done once in a year and you have some hazardous operations. A worker, skilled or unskilled, tends to forget some of the critical aspects and critical issues. I have rarely seen that before start of such campaign, there is sort of a training or some revision or revisiting the issues, which needs to be done, because this is something very critical, which is at times overlooked.
And I think one of the other things what you possibly want to do is also, because you have Indian Chemical Manufacturers Associations and so many other bodies in India, and some of those trainings and other things, I'm sure it is happening, but based on some of the lessons learned, or like how we are doing knowledge sharing today, this should be done frequently, and people from various levels should be sent or educated that, okay, this has happened, this is what you will be careful about. I have seen, at least in the US, in different plants, that if the incident has happened, say the plant in Texas, then the plant in Pennsylvania would take that as an incident and train their people that, okay, this is lessons learned, we would not make the same mistake. And as Anil has said, it's an ongoing process. So there is no substitute for training, communication, and awareness. It has to be ongoing always.
I think one of the challenges is the diversity of the chemical industry, the kind of processes that we handle, the number of chemicals that we use. In homogeneous industries, and I give an example of the chloralkali industry for one. I mean, I have seen my experience over tracking this industry for so many years is that they have done a pretty good job of learning from each other. But in the broader chemical industry, with its disparities in terms of size, in terms of the technologies, in terms of the processes, etc., those learnings have been shared to a far lesser extent. Ranjan Rajkova has an interesting point. He says many senior process safety people are retiring, but their sons and nephews don't want to work in a plant, and they rather prefer a cool job in front of a computer in an office. How are we going to handle this? I think this is a larger issue of attracting talent to the chemical industry per se, and I think it's something that is challenging companies in India, and I guess it's challenging them in the United States as well.
Yeah,
that's a global problem.
Yeah. So I think just pay better.
Ravi, we have just a few minutes left.
Yes,
So we
yes.
need to wrap
Pay better, and make them cybersecurity savvy. So
Right.
if they make them.
So I need to wrap up the Q&A sessions, and thanks for sending in all the inputs. I'm going to hand over the floor quickly to Deepak for making some closing remarks and call the conference to a close.
Yeah.
Deepak, the floor is yours.
Yes. Thanks, Ravi. I'll just make I've just a couple of slides. I'll talk about some of my experiences and observations in the Indian industry. I think so. First of all, Anil and Ashit has given some excellent overview of the cybersecurity as well as starting post-COVID, not just COVID, but post any shutdown in any chemical industry. Some of the key issue I have personally seen pertaining to Indian industries, by and large, SHE, safety, health and environment is a neglected area in Indian chemical industry, except possibly in the big companies and multinational companies. Most of the small, medium scale companies do not have any dedicated person. It's generally a managed or some makeshift person trying to manage something, if at all. Otherwise, there is hardly any safety person or environmental person seen around. There is limited involvement of senior management in safety and environment. As Anil has stressed all throughout, it's very, very important that the top management do get involved in all the aspects. Besides, everybody who is managing the operation needs to be part of leadership of the safety issues. Many times operations are managed by unskilled or semi-skilled workers, and at times persons may not have, the person managing it will have very limited technical knowledge. And this also, as Ashit has shown, could be some of the, in some of the accidents which have happened, this could be one of the major issue which could have led to those accidents. Then there is lack of regular training to operators and supervisors on the hazardous operations. Which I mentioned some time back, that there is, especially in the batch process, when you do a campaign once in a year, say you are doing some fluorination or some nitration, there is, that person may have forgotten some of the critical steps and critical aspects. So in such cases, it is better that you have some small training session before you start that campaign for that specific product with those hazardous chemistry. And something which I have seen is whenever you try to scale up any new operations from laboratory to commercial or pilot or commercial level, there needs to be a HAZOP study done, which quite a few times is, especially in medium small companies, is just overlooked. People just tend to go from possibly a lab level to commercial level. Anil, can you change the
Yeah.
Way forward, it's interesting thing. A couple of weeks back, Professor M.M. Sharma had given a interview on which I went through. Very interesting one on the current scenario, and when he was asked about what is the cause of some of the safety incidents in Indian industry in recent times, he said very nicely, it's a sheer negligence, usually human error. And this is a science-based industry, and there is no place for any quacks. And we need to have strict vigilance by senior technical persons. And he ultimately ended his answer by saying that we should have safety norms which are like in nuclear plant. A very, very tall order for that to start with at present in Indian industry. But I think so it's something which is a very, very interesting statement which he has done. And I believe that it should be the objective, but we should really try to improve on the safety norms, need to lay down safety norms properly and implement them as well appropriately. I believe some of the reasons for one way forward is possibly to do some better automation of the operations wherever possible, and employing trained technical persons, especially to operate any hazardous plants or hazardous chemistry. Don't leave it to any unskilled workers. Regular training of employees is another way of ensuring that handling of such hazardous operation is done with lesser risk. I won't say there is no risk, but it could be lesser risk. Another suggestion could be annual third-party safety audit, which I have seen some of the even medium-scale companies do. If annual, some of them do it once in 2 years, once in 3 years. So they bring in third-party auditors to help them to improve their safety norms. And most important thing, as we have discussed during the Q&A session, the systematic analysis and assessment of accidents and sharing of the findings is a very, very important thing which the Indian industry should work with. And this could help possibly to reduce the accidents, and improve the safety norms in India. Lastly, I would like to thank all the participants who joined the webinar. And also thanks to Ravi and CCPS for co-hosting it. And the last but not the least, to my two batchmates, colleagues, friends, Ashit Dalal and Anil Gokhale, for spending their valuable time to educate and present their thoughts on this important topic of safety in chemical industry. Thanks a lot. Last thing is, as Ravi has said, we will be sending feedback form. So if you can put in your feedback, you will get access to the presentation as well as the recording. Thanks. Ravi?
Thank you very much. So I don't have anything really more to add. Thank you guys for being part of this event.
Only one thing I will add, Ravi, on what Deepak has said, that doing annual third-party safety audit is a great idea. It should be done. But it should not just be done by the third party. There has to be internally, there has to be continuous check. There is something called as an internal audit, internal safety inspection, and there is no substitute for that. Second thing is the third party safety audit should not be just checkbox audit. It should be a very meaningful value-added audit and very, very honest audit that should be brought down to the attention of the management that these are the issues, it needs to be fixed ASAP. And then only you will be able to see the safety culture percolating across the organization. That was my comment.
Ashit, I'll let you have the last word. And thank you, all of you, for being part of this.
Thank you.
Good evening.
Thanks a lot.